everyone, and thank you for joining us on this webinar today. Your presenter is Paul King. He's a member of the Groovy Grails and Micronaut core development team here in Object Computing. Today, Paul is going to review the key benefits of using Groovy, including integration with various JDK libraries commonly used in data science solutions. And we hope you enjoy the presentation today. So with that, Paul, I will turn it over to you.
Thank you, Jen. Welcome, everybody. Good morning, Wednesday time for anyone else in Australia who's just woken up like I have, or good afternoon or good evening for wherever else people might be watching or listening. My name's Paul King. As Jen mentioned, I work on the Groovy Grails and Micronaut team at OCI. I'm the lead of the Apache Groovy project as well, and author of the Groovy in Action book. So some of you might be OCI machine learning customers. You may not know that there's a bunch of experts, in object computing that are in the Groovy Grails and Micronaut space. And those in the Groovy Grails and Micronaut space might not know that there's also teams of people in other areas, including machine learning. So I'm just a dabbler in data science, but there's a whole team of experts in OCI that if you've got any deep questions on data science, you can go speak to them. But by all means, fire questions at me and I'll give you my view, but there'll be more in-depth feedback that you can get from a whole team of people. So what I'm going to do today is talk about Groovy in the context of it being a useful language for data science. And to complete that picture, some of you may not know much about Groovy, so I'll quickly run through some of its features. So Groovy is kind of like a super version of Java, is one way to think of it. So it supports nearly all of the Java syntax. And indeed, when it was created, the inventors of the language were very much wanting a language that looked and felt like Java, but allowed them to have the ability to do scripting tasks and other things in a much more productive way than what Java would allow you to do, and have features that were being incorporated in other languages at the time that made you very productive. Some languages, Python, Ruby, Smalltalk, among others. So the idea with Groovy was, let's allow all the syntax that you can have in Java, but if you want to, you can use shorthands, use high-power constructs to get rid of some of the boilerplate code that you typically have in Java code. While at the same time, though, remaining very, very close to Java in terms of the security model, the object model, all the details of how your program runs are almost identical to how a Java program runs. So the bytecode that Groovy is producing, in some cases, will be very similar to what a Java program would be. In other cases, will have some extra dynamic capabilities woven into the bytecode. So Groovy has both a static and a dynamic nature. So the static nature is to align itself with Java. So there's many times when you want to have the strong compile time type checking that Java will give you, and Groovy will let you do that. But at times when you don't want to have be bothered with the type information, you're allowed to leave it off, and you gain duck typing, and you potentially gain simpler looking programs. And for a data scientist who doesn't want to necessarily spend their whole life keeping a compiler happy, that can be a huge bonus. The other thing that the language has always been extensible, both the language and the tooling. So anything that the creators of the language have needed in order to add the bells and whistles that make Groovy the productive environment that it is, have been opened up to users. So we'll see a couple of those things as we go along. So the good news is that if you already know Java, Groovy's got a very, very low learning curve. You can just cut and paste most Java code that you see on the web, cut and paste it into the groovyConsole, or run it via the Groovy REPL, or compile it up with the Groovy compiler, and it'll run fine, apart from some very minor exceptions which are documented. So that's good news. The other thing which if you're a Python programmer, you may not realize that even though the syntax of Groovy will have a lot of Java flavor about it, in terms of style, it mimics a lot of what Python and other languages, some of the functional languages do. So we'll see some examples of that a little bit later on. And as I mentioned before, Groovy's tried very, very closely to maintain the feel of what a Java program would feel like to a developer, and that includes the sort of the runtime model. So if you're going to go and use some of the other JVM languages that we're lucky to have a range of very, very useful languages available to us if we're on the JVM. Many of them, though, will realign various aspects of the language. They'll have different types for lists or strings or dates or whatever it might be, or they may do inheritance hierarchies in a different fashion or whatever it might be. One of the things that Groovy's tried to do is align itself very, very closely with Java. And that means that when you go and look at all your data science libraries on the web and you see, oh, this one supports language X, Y, and Z, if one of those languages is Java, then in fact it supports Java and Groovy. So Groovy will just slot right in. You'll be able to use it pretty much as they say, out of the box with the Java code. You'll be able to use that as Groovy code, or you can simplify it down, and we'll see some examples of what that would look like. So this is an example of some code. I'm not going to go into the details. I have quite a few slides with code on that I won't be going into the fine detail of. Don't stress, all the code, if you're wanting to see it, all the slides will be published and all the code will be on a GitHub repo. Most of it's there already, but there's a couple of extra examples I'll put up shortly. So on the left-hand half of this screen is some Java code for manipulating lists. And it's actually valid Groovy code as well. And even back 5 years ago, the code on the left would have been what you'd consider sort of best practice Java code back then. You can now improve it with later versions of Java, but even back then, Groovy can do all the code that's on the left, or it can simplify it and give you the code that's on the right. And that's using some of the syntax shortcuts and the succinct syntax constructs that are in Groovy. So if you want to, you can use what you're familiar with, if you're familiar with Java, or you can get a language that's, in style, it's very similar to Java in syntax, but it's similar to what a language like Ruby or Python or so on might give you. And one of the other things that Groovy does is actually lets you, it's got very good DSL support. What's a DSL? It's a domain-specific language. So when you're talking to a database, you might use SQL. So it's a language, if you like, with nouns and verbs to select things from columns in a database. So you'll have nouns and verbs describing the actions that you want to take place and the things you want to perform those actions on. And a DSL is a language that supports DSLs allows you to get as close as you can to what a domain expert would use if they were describing their area. So even the code that's on the right-hand side here, Groovy would say sometimes that's still not in the right form that you might want to have. And you can change the form to be this sort of style here if you wanted to. And I've written it in English here, but it could be in Japanese or Chinese characters if you want. And that's also a valid Groovy program. So it looks like it's just text file with some words and spaces in it, but that's all valid Groovy code. And I'll explain a tiny bit about that, but the details of that aren't too important for today. There are other capabilities of the language. There's metaprogramming capability, which allows you either at runtime or at compile time to change the language itself. So up the top half of the screen, or top 2/3 of the screen, is some Java code for doing what you might have. It would be considered best practice for Java if you want immutable objects in Java out of the box. So you might get some frameworks that'll help you with this, but if you're trying to get immutable objects out of the box, this is the kind of code that you would typically write. And there are books that describe the design patterns involved in that code. So it's not once you're familiar with those design patterns, you can certainly churn out code like that. But it's a lot simpler in Groovy just to use a declarative style and just say this is an immutable class and here's the properties of the class. And Groovy then goes and basically under the covers puts in all that stuff that's up the top. So that if I go and use my Groovy class in combination with some Java classes, it'll look exactly like what they're expecting to see. So Groovy lets you do the simpler thing. It makes the code much more readable and maintainable, but it's actually producing stuff that conforms with all the best practices that you'd expect in Java land. Here's there's a very nice library for data science. It's got mathematical libraries and some machine learning, linear regression, statistics, and so on. It's called Apache Commons Maths. There's a few of them. We're going to get a list. We're going to have a list of other ones shortly. But here's the typical Java code you would use to do some matrix calculations in using that particular library. So we've got a class here with a method inside it, and then we're defining some real matrices using some methods available out of that library. And then we can do things, once we've created a matrix called M and another one called N, we can multiply those together and so on and so forth. We can find the inverse by getting a solver that'll do the appropriate matrix calculation to get the inverse of that matrix. So that's the code there. And if you run that, you'll see the little line down the bottom when you print out the matrix that's calculated. So it's got, that matrix has got its own two-string behavior which prints out the information that's in the matrix. And it's a 2x2 matrix, so you can just make that out by seeing some curly braces there and a comma on in the middle of the screen, and on the right-hand side of the screen there's another pair of numbers in curly braces with a comma. So it's all the data's there, it all makes sense. What Groovy would allow you to do is apply a bit of metaprogramming, some operator overloading, and potentially even there's extensions to the tools that let you describe any data type that you've got, how you want it to be represented. So in Groovy, you'd do this for that same code that we saw before. So it's rather than getting a solver and getting the inverse, there's just a tilde symbol there, that's operator overloading. There's some operator overloading for multiply and squaring and both scalar and matrix multiplication. So this would be typically what you would do if you were a data scientist. You'd set up your groovyConsole to understand the data types that you're dealing with, and then you've got a nice, pretty graphical representation of the matrix as well in that little thing. So this isn't just something well, in fact, this isn't built into Groovy. So I added a little 6-line class to script to do the matrix representation that you see on that slide. The important part about it is that it's all extensible. So whatever your field is, you can easily write a little script, and it can be images, it can be a 3D graph, it can be videos, audio, whatever is appropriate for your application once it completes. That can be what you configure the console up to support. Now we're going to become machine learning, natural language processing area. We're going to become experts in 4 or 5 lines of code. So I'm going to use the groovyConsole. I'm using a thing called @grab, and that'll actually just automatically download all the libraries that this particular script needs, which is just one library. So this is Apache Open NLP that I'm going to use here. So it'll automatically download as part of this script. So this is a nice feature that you can embed the metadata about what your script needs all inside the script. So there's no, I can email this script to somebody. I don't need to tell them, I'll go and install this particular library, this plugin, this extension, this class path thing, this particular thing in their system. They can just cut and paste this into their groovyConsole and run it. And all the things that it needs to run get downloaded as it's executing. So here we're going to, there's a pre-canned language detection model that we're going to pull down. And we're going to feed that into our detector model. We've got two particular phrases here. And I'm naively going to think that they're both the same language. I'm going to guess that both those statements are in the same language. I feed it into the groovyConsole and I run the script, and it quickly tells me that my language skills need a bit of brushing up. And in fact, I've got a French and a Danish two phrases there, and the language detector has detected them. And even in the little presentation that you see here is what's called the power assert. So when the assert fails, it doesn't just tell you, no, it failed, it went wrong. It teases apart all the bits of information out of the individual expressions that make up that assertion. So in this particular case, we're seeing that we've got the language detector, we're seeing the language it's predicting, we're even getting information about how confident about the predictions it is. It's hard to get a high confidence level with only 2 or 3 words. It's feeding in all the A and B strings. You can see them appearing, and then you can see the result coming back France and Danish. So we've got some French and some Danish text there. So I could now go fix my program and rerun it, and I wouldn't get that display. But when things do go wrong, it's very nice to have that sort of feature. There's another little tool called the Groovy REPL, which lets you do interactive programming. So you've probably seen these sorts of things before, little shell environments or REPL environments where you can type stuff in. So here we're going to we're going to use that grab capability. We're going to pull down a little ASCII graphing app, gives us ASCII art, and we're going to create a sine wave function. And then we're going to print out the function with 15 rows, and we're going to plot it, and then we get the result. Okay, so that's nothing new to what you've seen before, but just for those who haven't seen this sort of stuff before. Now this is just going back to the DSL information that I saw before. I mentioned before. So up in the left-hand box on your screen there, it looks like, cranes have 2 legs, tortoises have 4 legs, and so it looks like some text, but that's not a text file. That's a statically typed Groovy program. And in fact, this Groovy program won't compile if the animals that you list in it aren't found in an online database of animals. So if I put in cranes and tortoises, it finds both of those. If I put in dragons and unicorns, the program might fail. It might find dragons because there's water dragons and things like that. It'll be in the database, but unicorns unfortunately may not be in the database that I'm using for this particular program, and so the program won't even compile. Once the program does compile, this particular program underneath the covers calls a constraint programming solver. And I'll quickly look at a constraint programming solver as something you might want to use in your data science because it overlaps. Linear programming is sort of one of the things that they support, among other things, and that's something that can be quite useful for optimization. So just looking at this program again, we can add another line of code and rerun the program, and it re-invokes the constraint programming solver, and we get a different solution. Okay, now that's a little DSL. So somewhere I've gone and defined a bit of code that represents what all the bits of that DSL mean. So when you call cranes have 2 legs, it's actually underneath the covers storing away information in like a a dictionary or a hash map. So cranes have 2 legs. It'll have cranes as a key and 2 as a value and things like that. When you say display solution, it goes and invokes a constraint programming solver. So all the details of that are stored away in a little DSL. And Groovy gives you the option of making that visible so that everyone can see it, or hiding it away if you don't want people to see it. Like the when we were using the matrix calculation before with Apache Commons Math, it was up to me to decide how much of that do I make visible. So do I want to show people what particular classes they're importing, or do I want to have those hidden away and automatically imported matrices and things like that? So Groovy gives you a lot of flexibility in that fashion. Now there's a huge library of Groovy specific frameworks in the Groovy ecosystem. I haven't really got time to talk about most of them. All the ones mentioned here, a bunch more, and then there's every single library in the Java ecosystem is also things that we'd typically be using every day. I'll just mention a couple of them briefly here. Well, Micronaut I'm going to come back to, but BeakerX I'm going to come back to. Just going to mention a couple of other ones that you might find useful. For data science, the Spock framework is a framework that people in the Groovy ecosystem use for testing, and allows you to write tests in a very nice compact form. That's just one example of it there, little sort of tabular form. Gradle is something that you use for building your systems. So if you can use Groovy is a nice language you can use with that. It's got a couple of languages it supports. Groovy is a good option if you're coming to this from the data science world. Jeepers, won't have time to talk about that today, but it's a full parallelism and concurrency library. It's got a whole bunch of it supports actors and data flow and a bunch of things for highly embarrassingly parallel activities. So if you've got a large collections of things that you need to perform the same operation on, there's very, very nice ways of coordinating how that would work. Okay, don't have time to go into more details, but just be aware there's probably a whole lot of other things that you'll find useful. Okay, so getting on to data science, there's lots of ways I could describe the process. I'm not going to give you a tutorial on data science. As I said, there's a whole floor full of people in the OCI building who will happily talk to you if you want to dive into all the details. The reason why I'm interested in is twofold. First of all, it's an area that I dabble in, and there's different times where it's become quite important in some of my the client work that I do every now and then. But also within the Groovy ecosystem, we are getting a lot of interest in data scientists, in Groovy from data scientists. So there's a lot of them of saying, oh, there's this really wonderful Java library that I'd like to use, but the Python interface, the Python API to it's much easier to use, so I'm just going to use Python. And that'll limit me to a subset of the available options now, because there was this other library that looked interesting. And then they've sort of discovered Groovy and said, oh, I can actually write Python-like code. It's simple to write like the Python stuff I'm used to, and I can still talk to all those Java libraries. I never knew that. And so we're getting more and more interest from people that are falling into that category, and they're asking us for more and more features in the language to make the base Groovy facilities better support data science. So we're going to be doing that. So like the little groovyConsole that you saw before, it's not going to be as powerful as some other things we'll talk about very shortly that some of you will be already familiar with, but it's kind of really handy just to have it there when you're doing little scripts in Groovy. So we'll be enhancing that in a number of ways, and you'll see things like that, enhancements in the tooling, enhancements in the libraries to make Groovy more data science friendly. And you'll see that over time. So here's some of the things that you might want to do in data science. You might want to obtain your data, you're going to ingest data. You might want to do some data wrangling on it, so you might need to clean it or transform it or do various kinds of pivoting or whatever you need to do, handling missing data, handling bad data, finding outliers, all that sort of stuff. You're going to want to explore your data. So you're wanting to investigate, find out information about your data, features that you think are interesting, and selecting features and so on. Do some data modeling, so looking for various algorithms, visualizing the data that you have, and if you do transformations, the results of doing your transformations. Or if you do go build models, you want to analyze how well those models are with fresh data and so on, and validate it and cross-validate it and all those sorts of things. So that's sort of the cycle, and you're going to once you get more insight in your data, you'll just keep spinning around, and you'll probably see other terms mentioned: data ingestion, data storage, data processing platforms, if you want to do sort of big number crunching and so on. They're all the kind of things that we'll mention. Now, what I was going to just briefly pause here and sort of reflect on how does the Java, the JVM ecosystem, in which Groovy sits, so Groovy, Java, and the other alternative JVM languages, how does it supply tools or scripts and things that allow you to plug the gaps that are in this picture, or do useful things for all the boxes and clouds in this picture. And what I would say is that in many of the places here, Groovy's got some real strengths, and Java's got some real strengths. So if you're integrating with other systems, there's huge amount of libraries for doing that, and we'll look at some of them shortly. In the number crunching, the data processing platform's very, very strong. There are some good graphics libraries. I wouldn't say that, well, there's some really good graphics libraries, but I wouldn't say that they're as strong a ties back to the data science world as for other languages like Python and R. So to cut a long story short, in most of the boxes and clouds in that picture, there's a good story, but where the JVM world is slightly weaker than perhaps Python and R would be in supplying everything that you see there, tying it back to how a data scientist would want to work in that world. And that's something that the JVM world is only is playing a little bit of catch up in my mind. But there's some good signs there, and we'll see some of that. So I'll quickly just while we're sort of pontificating language choices, I'll quickly look at where Python and R plug in some of the boxes here, and then we'll look at what the JVM world can give you. So if you look at R first, it has various libraries for doing data wrangling and graphing and all the different kinds of things that I was mentioning before. And if you look at, first of all, there's some really good options, but some of those options in this, the detail on this slide is not important, but what you can see here is that some of the libraries have hundreds of contributors on. So I doubt that, so there's 3 or 4 of the libraries on that slide that have got more than 100 or more contributors on it and thousands of commits. I think you would be hard pressed to find Java data science libraries with that level of interest at the moment. But there's some good catch up being had. There's some really nice libraries. I'm going to talk about a few of them, but there's that's the area where I think we can learn a lot from some of these other languages. Similar story for Python. So you can see there, Pandas, it looks like it's just about at 1,500. I checked their GitHub site in the last 24 hours, and I think they're now over the 1,500 contributors. So that's a very large number of contributors to Pandas libraries, which is a library for doing data manipulation in Python, for those who don't know about it. And I also looked at the reverse dependency list for Pandas, and there was something like 28,000 projects that depend on that library. Now that's not, many of those will be people's, they are playing with it, trying it out and whatever, and they put up a little GitHub project or whatever, and it's got a dependency to it. But there is a whole bunch of legitimate other libraries that sit on top of it and extend it and do wonderful things. So again, there is not really anything in the JVM world that's got that level of sort of penetration in terms of giving data science, raising it up to be something that's permeating through a whole bunch of different libraries and you know, with shared representations of the data and so on. Now that's starting to come about, and I'll show you some libraries in a minute, but that's again an area that we're certainly, I think the JVM world is certainly in catch-up mode. So if you're in the Python and R worlds, I'm not, you know, you're in and that's what you know, and that's the ecosystems that you're familiar with. You're in a good space. That's good. If you need to integrate into the Java world, and there's lots of benefits, as I said, in other areas in the computing engines and integration aspects in the Java world, there's many strengths. If you need to hook into that, then the options that we're going to look at next is the path forward. So that's what those two languages give you. Let's look at now where the JVM world and Groovy can give you options in all of the boxes. Now, first thing you might want to do is obtain your data. So you're going to identify the sources of data, and you'll be doing things like clarifying the ownership and checking the quality. That's all understood. What are the sources? You'll need to check. Some of them might be data providers that are external. Some will be internal. You'll have different kinds of data. You'll have databases. You'll have files, events. You might have, in the Internet of Things space, you might have all sorts of event information that's piling in at an enormous rate. So it'll be streams. You might need real-time streams of data there. Some of it will be structured. Some will be unstructured. There'll be various kinds of things: text, XML, JSONs, CSV files. Could be images, video, audio. Could be web services. So there could be a whole range of different things. Groovy will give you pretty good facilities to do all of that stuff really easily. So part of its heritage was we're going to make it easy to do scripty type things. So if you wanted to do scripts in Groovy to pull a whole bunch of data out of an XML file and put it back into a CSV file, or whatever particular thing you might be wanting to do, merging stuff out of a relational and a NoSQL database, you'll find that Groovy's got a whole range of facilities that'll give you that capability. There's a couple of examples of JSON slurpers, XML slurpers, and SQL querying on the right-hand side. The details of that aren't important, but the one important thing to sort of be aware of is that the Groovy APIs allow you to get to all these different data sources in a mostly similar fashion. So if once you've learned one of these, you'll find that picking up any of the other ones will be fairly easy for you to do. A couple of while we're in this sort of pulling data out of files and stuff mindset, a couple of Java libraries there. Apache Tika will let you pull data and metadata out of something like 1,000 different formats. So it'll pull metadata out of an image, or out of potentially out of audio and video files. It'll pull text out of PDF files, all sorts of different information that it can pull out. Apache Poi will let you interact, so reading and writing Office files, and JXL does the same thing just for Excel files. So there's a whole bunch of information, a whole bunch of libraries there that allow you to easily get to data. Okay, so we'll look at, I'll have some little Excel spreadsheets coming up, and we could easily be pulling those in to our Groovy script using these libraries. Data preparation. So Groovy's, Java's got a whole bunch of, it's got a whole collections API. Groovy enhances that with a bunch of features to make it more compact and easier to deal with, and doing the map, filter, reduce style operations. You can use the Later versions of Java also have streams that mimic some of those capabilities, and you can do all that stream stuff as well. There's a bunch of other libraries you can use for collections, but what is becoming more prevalent, and I'm hoping this trend continues, is that there's now some libraries emerging for doing kind of data frames. So we don't just want a list or a map or a dictionary of information. We want a data frame that's actually capturing that information in a form that a data scientist can say, yeah, I know what this is. I can describe it. I can pass this around to I can hand it over to a plotting library. I can pass it to some sort of modeling engine, and they'll all know what to do with it because of the way it's stored and the sort of the common data structures. And so there's a bunch of them around. Joinery, table saw, Apache Spark has some data frames capabilities, and Paleo. Not sure how widely used that last one is, but the other ones certainly seem to be in widespread use and growing. I'm hoping that they spread. I'm hoping that we can find a way to make data frames a much more important part that spreads to a whole range of different parts of the JVM ecosystem. So fingers crossed that that's going to keep spreading. Now, the next thing you want to do is data exploration, and I'm going to show you how you do that with a little bit of scripting shortly, but there is a couple of JVM-based tools that you might want to make use of. So one of them is called Dex. It's written in Groovy. It makes use of JavaFX. And you can see the little GUI for that application on the right. And it gives you a little menu. You can see things like there's Groovy and Jython scripts, there's Groovy filters, there's CSV reading and so on, there's graphing capabilities. And so what you do is you do a little mini workflow of your data exploration activity. So you might read in a CSV file, you might then do some transformations on it, might do some modeling on it, whatever it might be, then you might do some graphing. And you'll have those as a series of steps, and you can execute those, and you can have pretty graphs produced or data manipulated and so on. So it integrates in with Smile and R. So if you're already familiar with some of the capabilities for doing visualization or data manipulation in those environments, you can do some of that hook directly into that. The next one, and we're going to come back to Weka because it's got some really useful features. Is Weka, and it's from as we would say in Australia, it's from across the ditch. So it's over in New Zealand, which is just not too far away from where I live, but just a bit of an ocean in between me and them. And it's a very, very well-known library, and it's got a whole range of capabilities built into it. So we'll come back and look at we'll play with that to do a little bit of a linear regression problem shortly. One of the nice things about it is that it has the groovyConsole that I showed you before is all built in, so you can be working your way on your models. You can dive out to the groovyConsole, do a bit of scripting, produce some graphs like what's shown here. If what you're wanting to do is not supported inside Weka itself, you can easily dive out, do some extra stuff, and then go back to using Weka in its traditional form. So that's something you might want to look at. There's a whole range of visualization libraries as well. Now, as I was saying before, the difference to how the situation is, well, if we step back 2 years in the JVM world, all of these libraries allow you to do excellent graphs, but they'll all have a different representation of how to call them and what you feed into them and so on. And what we've seen in the Python and R world is that there's more and more of the frameworks supporting things like data frames. So we're just starting to see that sort of movement happening in the JVM world. So hoping that that's going to work well. I'll mention GroovyFX as well. We're going to come back and it's got a whole range of graphics capabilities, many graphics capabilities, and we'll just do a tiny little tiny bit with that tool in a moment. Notebooks. So many of you have probably used Jupyter, or there's a few other options in the Python and R worlds. They were kind of unknown to many of us in the JVM world until a few years back, and things like Groovy Lab and then Zeppelin and others started to appear on our horizons, and they're still around. But the one that's got the most traction at the moment is probably the Jupyter Notebook capability, and you'll be pleased to know that there's a BeakerX plugin for that lets you hook into all the JVM languages. Okay, so this one's showing you a couple of graphs that are using Groovy, but you can create notebooks with most of the JVM languages and do similar things from the other JVM languages. Okay, there's some of the other tools, Apache Zeppelin, Groovy Lab. They've got some really neat capabilities as well, but at least from where I sit, they don't seem to have the same traction as the BeakerX stuff. But who knows? We'll see. They've got some strengths where they would be still useful, and who knows where they're going to head. But yeah, keep them in mind if the BeakerX stuff isn't keeping you happy. Now, I'm going to quickly whiz through some. There's more Java libraries that I haven't really gone into detail. So all your input and output for reading files. Java's got great capabilities for that. Groovy provides a whole lot of enhancements. There's a bunch of other libraries. If you want to do web scraping, I could list you off 10 libraries in the Java ecosystem for doing that sort of thing with various capabilities. Jeb is a good option in the Groovy world. It's got a nice, it's like a DSL, if you like, that I was showing you before. It's got a little mini language for interacting, both testing and screen scraping or web scraping websites. If you wanted to do batch processing or ETL, there's Apache Camel and Goblin do the ETL side of things. Goblin's designed for sort of more streams. Spring Batch lets you do batch processing if you want. Maths libraries. I already showed you Apache Commons Maths. It's got a whole lot of facilities I haven't told you about yet, optimization and things. We'll see a tiny bit of that in the next coming up shortly. Apache Mahout, I'm not sure if I've got the pronunciation right, but it's got some distributed linear algebra and machine learning capabilities. There's some other libraries that do very fast linear algebra, often requiring native packages on your system. So if your system supports them, they can get very high-speed calculations. And a lot of the machine learning libraries, they've got a slide coming up shortly, also have a little bit of stats and maths and linear algebra built into them because you often need all of those things in unison. Data storage, I said that there's really good options. Yeah, whether you've got graph databases, document-style databases all in the NoSQL space, or you've got relational databases, you'll have good options, and there's often either really good Java libraries that you can access from Groovy, or there's often special Groovy syntaxes that give you even more compact shorthands for accessing those databases. Okay, machine learning and data mining. I showed you Weka as an exploration tool, but there's actually a whole a large library of APIs that are bundled in that tool, but are also usable outside that tool. So yeah, it's a very, very good option for you to consider. Smile is another one that seems to be very actively developed. And the Apache Spark libraries might also be a good option as well. Okay, there's a bunch of things for neural networks and deep learning. So deep learning is really just multiple layers of neural networks, or multi-layered neural networks, if you like. And so if you're doing anything in that space, either video processing, image processing, audio processing, text searching of various kinds, then there's a bunch of useful libraries. So I already showed you the Apache OpenNLP in a little 4 or 5 line script comparing the French and the Danish text. So that's one example of this. Groovy's also got a whole bunch of enhancements for strings and regexes and things built in, but I won't go into those. If you're doing hardcore data science, you'll be wanting to move on to one of the packages. Okay, now scaling up. What do you want to? What things are you going to use if you actually have huge volumes of data, huge quantities of information coming in streams and so on? So this is actually one of the strengths in the Java world. There is a whole range of libraries. So just looking at the Apache stuff on the left-hand side, there's Hadoop, Spark, Flink, Samza, Kafka, Storm, Apex, Beam, Ignite, Niffy. So they're just some of the big data, distributed data processing libraries in Apache. And there's a whole bunch outside Apache as well. So some of them are for batch processing, some are for streams, some are for generic interfaces above all of the others, and some of a little bit older and more mature. They might concentrate on different kinds of things like storage or whatever it might be, but there's a whole range of options and there's some real strengths in some of the capabilities that are there. I'll show you a Apache Beam example with Groovy a bit later on, and a bunch of other ones as well. The other thing that I'll mention now, in case I don't get a lot of time later, is Micronaut. So quite often when you're involved in a data science activity, you might be creating models or data output from models, and you need a way to make that available for other parts of your system, and you might want to use a microservice. Then Micronaut is a really nice option to make that information available. You can make it, it'll only be a very small amount of work on your part, and you'll very, very quickly produce a microservice that's servicing the data that you're trying to make available. Machine learning algorithms, there's lots of them for regression, clustering, classification, deep learning, decision trees, and so on. The libraries that I talked about have various offerings spattered across this particular slide. I'm just going to look at one of them to start with, linear regression, and we'll go through this pretty quick because otherwise I'll run out of time. So this is just house sales predictions. So this is a typical linear regression type problem, and this is the house sales in King County, which includes Seattle. And it's between May 2014 and 2015. There's the house prices, which is the thing that we're interested in, and there's a bunch of other features or attributes that there's data being collected on these properties. Okay, so there's things like the number of bedrooms, number of bathrooms, the living space area, the condition of the overall condition of the house, and a bunch of other information. So the first thing I might want to do is explore that data, and we'll show you some tools in a minute, but what if we want to do that with scripts? I'm going to use Apache Commons CSV, which is a little CSV library, so I can read that in a couple of lines. I'm going to use Apache Commons Maths and store that in a little empirical distribution. Is something that I'd typically use to capture just any empirical data that I don't know is of a particular distribution. Then I might do things like capture it into bins, into chunks, like a histogram would give you. And that's what I'm doing here. And so I'm just grabbing all the data out of the CSV file, putting it into my distribution, and then I'm going to use groovyFX to show that up as a little bar chart. So here's the bar chart here. We can see, yep, lots of houses. I've just shown the bedroom count. So the middle line of those 5 lines in the top part of that slide is looking at the bedrooms. I've got this hunch that house prices is related to bedrooms. I've been in houses with lots of bedrooms and they cost more, so that's my hunch to start with. And we can see there's a whole bunch of houses with 2 bedrooms, a whole bunch with 3, and then a few more with 1 and 4. There's a whole bunch with 0, which I guess you're sleeping on the couch in those houses. And there's something funny happening over on the very far right-hand side of the screen. There's a whole bunch of blank space over there. So I'm kind of a bit worried about that blank space. So the next thing I might want to do is do a bit of exploration. And so again, if I'm using scripts, I can I can get some summary statistics, and that's another one of the library calls that one of the classes available to me in Commons Math. And I run that through, and it tells me that the maximum bedrooms is 33. That seems, that's a large number of bedrooms. I might want to, I'm a bit suspicious about that. I might want to look at that a bit further. So what I'm going to do now is, just print out with my script there. I can just print out all the information about all the properties which have more than 10 bedrooms. I'll print all those out. I'm putting it into a map so that I've got key value pairs showing up with a colon in between them. And there's only 2 properties with more than 10 bedrooms. One's got 11 and one's got 33. And I can look at those, and it's a bit suspicious, this 33. I can see that it's actually got not really any much more, it's got actually less living space than the 11 bedroom space. It's got less than 2 bathrooms, so I'm not sure where all those 33 people are going to, what facilities they're going to use. And there's everything else about that hints to me that perhaps there's someone's wanting to type in 3 bedrooms and they probably put in 33 or whatever. So I'm suspicious that this might be an outlier. So what I might want to do is get rid of that outlier. Or before we do that, here's another library, OpenCSV, just to show you the different flavors. Here I'm going to create classes, so domain classes for my house and so on. And the OpenCSV library will put the same information that we saw previously. It'll store it away in objects. So I can have a rich set of classes representing my domain if I want. Otherwise, I'll get the same info. You can see how it's presented there. Right, so what I'm going to do, I've decided that I'm going to remove that outlier. I could do many things here. I could adjust it. I could get rid of the outlying value and supply it with the average of that field. There's lots of things I could do. I'm just going to remove the value. So I'll just remove it, and then we'll just print it out again, and now we've got a more a less suspicious looking graph. Let's put it that way. Okay, so the next thing I might want to do is looking at the price. So I'm going to remove the outlier, like in the middle of the slide here, and then I'm going to collect the prices of all the properties. And lo and behold, similar sort of graph we saw before. And it's sort of skewed and it's pushed to the left. So maybe my hunch about this bedrooms and price, maybe that was a good hunch. Let's go a bit further. Let's now do a linear regression, and we'll do a simple linear regression on that the data there, and it's not many lines of code. And here we go. Here's what our predictor, a linear regression, is now. It's a prediction of what the house price should be. And the blue line represents what my prediction is going to be for the price of a house based on the number of bedrooms. And perhaps my hunch wasn't as good as I thought it was. There's a lot of properties in that graph there. They're going to be a long, long way from my prediction. So perhaps it was very naive of me to pick number of bedrooms. And in fact, it doesn't even look linear. It looks like it's going up in the middle and then down. So the most expensive properties peaks in the 5 to 6 bedrooms. After that, they're someone's building apartments or something, or they're not luxury homes anymore. So doing this exploration tells me, oh, yep, that was probably not a good idea to go forward with that as my regression. And this is where you might want to jump over to something like Weka. And Weka will actually let me play around a bit more. I could keep going as in the Groovy scripting, by the way, but it'll be faster with a tool like this. And as I said before, we can dive out to Groovy at any time. So here we're going to play with Weka. It'll show us all the features and graph them for me. I can then do some correlation analysis on those features. And in fact, it'll give me a list now of, here's all the on the left-hand side here, you can see sort of a table of ranked attributes. And so the square foot of living space, the overall grade or quality of the house, again, square feet of the top floors of and so on. The number of bathrooms is much more important than the number of bedrooms. The number of bedrooms is way down, what is it, 7th, 8th place. So it wasn't a good one for me to choose. But in fact, I shouldn't just go and pick the top one there. What you really want is to develop a model that actually incorporates a bunch of those attributes. And that's what Weka will let me do. I can go delete all the ones that I'm not interested in, and it can now save a model. There's the new ones, and they kind of all look like the price graph, which is good confirmation. I can go save that as a model and visualize it, and I've now got a model that I could use to then go and test additional data and do some housing predictions. So that kind of shows you one of these algorithms. And the next thing, you're going to want to go and train your data and then test it. And this Groovy's got some nice things for doing that. But we'll skip over that. Next thing you might want to do is scale it up. So when I was doing the linear regression there, that was all done in one process on my machine. The data processing platforms will allow you to spread that across either multiple threads or multiple processes or multiple clusters of machines. And so you can actually scale it up in a huge fashion, and they'll give you the capabilities to do that sort of thing. And I'll put a slide showing you how to do. There's an example. There's a link to an example in Java. I'll give you the Groovy version of that as well. They've it now only works on a snapshot version of Ignite. So I'll do some munging to see if I can get it working on a different version. Now we could do that same thing for classification and a whole bunch of these other things here. We don't really have time to do that, but you do a similar sort of thing. There's a whole bunch of Java libraries you can use from Groovy. Many of the tools, both the BeakerX and the things like Weka and all the other machine learning libraries will let you do this sort of thing. Now, we haven't got a lot of time left, but I just want to come back to some of the central messages, and then we'll finish on showing you a bunch of Groovy things in some of the other data processing frameworks. So another area that overlaps with data science is sort of the area of constraint programming or linear programming. So this is sort of the area of optimization. And the reason why I'm wanting to show you this is to give you, and we'll skip over where it gets used. It's used in quite a few different domains. This is a sort of a problem-solving area. And what I'm wanting to illustrate here is if you're a Python person and you're worried that Groovy is going to be a very, very foreign thing for you to pick up, this is a little send more money. It's a little puzzle that you'd give as a child. You'd probably given it in school, and you've got to replace the letters here with numbers. You can't put a 0 on the S or the M, and if an M appears twice, it has to be the same number, and all the digits have to be unique. So it's kind of a logic solving problem, and you can solve that sort of brute force in Python. And it turns out the brute force in Groovy is very similar. You can also use iter tools in Python, which are combinations and permutations. Again, very, very similar in Groovy. You can go use a constraint programming library, and the Groovy one and the Python one are again very, very similar. So if you're coming from a Python world you don't need to be scared of Groovy. You'll even though the syntax will be a bit different, there's white space rules that are different. There's curly brackets that you might got sharp edges until you get used to them. So there'll be a few things that are different, but there'll be a lot of familiarity as well. We can do the same kind of analysis for another optimization problem. So this is a straight linear programming optimization problem. This is trying to work out the lowest cost for a diet that has certain constraints on it. Now you can go and solve this in Excel. It's got solver capabilities. You mark certain parts of your spreadsheet as variables that you want to change, something you want to minimize, and so on, and it'll go and solve it for you. So it's not hard to do. You can do the same thing in Google Sheets. It's not an Excel specific thing. We can do the same thing in code. And there's a bunch of libraries that you can make use of. Here's one particular one. There's another one here that only does integers, so there's a little workaround for integers. Or you can have a C++ native library underneath the same one that I showed you on the previous slide, and you can solve it using reals as well in high speed. So I've just got a small, I know I've used up all my time, so I'm not going to keep you much longer. I've just got a small number of slides that are showing Groovy being used in the big data space. And it's a common theme across all of these libraries. You may not realize that they support Groovy because they often don't mention it. They will say that they support Java, and that means they support Groovy. So this is Apache Spark, and this is using, sorry, it's a boring example. It's a word count. I'll do a machine learning one next time. But if you go and get the Java Quick Start, take the code for that, you can shrink it down to about half its size, and it just runs with Groovy. We can do the same thing with Apache Beam. So Apache Beam is a uniform layer that allows you to talk from multiple languages to multiple big data pipeline runners. And you can go and there's a quick start. You can follow the instructions using Maven or whatever. You can see here there's Spark and Flink and Apex and all sorts of Samza, all sorts of options that you can pick and so on. You can to make all that available. There's some nice katas that you can go and there's a plugin for IntelliJ or PyCharm where you can go and do the Python and the Java versions for this. But you can just go and run this, cut and paste this Groovy script into the groovyConsole, and the same example is going to run. So this one here is doing a word count of, and banana appears 4 times in that little list of 2 lines there, and so on. Last one is MXNet. So this is deep learning. So I haven't got time to go into the details of deep learning. It'll tell you that it's got multiple languages. It's got a Java API, so it's got a Groovy API. And we can just go and write a small amount of Groovy. So we've got something that downloads a file, downloads some pre-trained data on different kinds of objects. And then we create an object detector, and we feed it a starting shape to go start exploring. And it comes back and it finds 3 objects that it knows about in its learned data. One is a dog with 0.8% probability. One's a bicycle with 0.9, and it's very, very confident that there's also a car in that image. So that's and it gives you the coordinates of where it found the objects that it detected. So you can see not many lines of Groovy code, and you can go and use MXNet, which is this a large high-scale machine learning environment, deep learning environment. So Groovy is a good option for using all these. Go and play. Okay, a little bit more info if you're wanting to know more about the Groovy community. There's some links there that I won't pause on them because you'll see those. But yeah, easy to find on Twitter or in the Groovy mailing lists or anywhere. And the object computing people, the machine learning group, and the Micronaut Grails and Groovy people, we're all easy to find if you've got any things you want to talk about, how this sort of stuff might be applicable to you. Okay, I think I've used up my time.
Thank you all again for coming, and we will see you next time.
Great work, Paul. Thank you very much.
thanks for listening. And anyway, if there's anyone still here that is a data scientist and you're interested in using Groovy and you think it's got missing some features that you think you need, by all means, give us feedback. We're a friendly community and we'd love to hear from you. Thanks, everyone.
Thank you.